Okay, hi there, everyone. So I'm not here today, but we still can talk about slope as the rate of change. Okay, so the rate of change is how fast the thing changes over time. Okay, so it's the rate of something changing. Okay, but rate of change is just another way to say slope. Okay, which remember is represented by f. The rate of change and slope are the same thing. Just like it was also the multiplier, right? We'll see that there are many different things that we can call slope, but it's all
Please excuse the interruption. This is just one final reminder to our grade 12 the OSAT presentation is tomorrow at 8:30, and you must have signed up on the sheet outside of student services by 2:10 today. There'll be no late signups.
okay. So there are several different ways to determine the slope of a line. We talked about rise over run yesterday, but there's also this delta y over delta x, and that delta, the Greek letter, that's what the triangle is. It just means difference. So it's difference in the y coordinates over the difference in the x coordinates, which is our rise and run. Because y was up and down, that was my rise. The difference in my x, side to side, that was my run. Okay. The other way to put that into point notation, when we have 2 points, is to do y2 minus y1 all over x2 minus x1. Okay, I'm going to get back to the y-intercept in a minute, but first I want to determine the slope of the line. Okay, so I want to choose 2 points and determine the slope. So I'm going to go right where the line crosses over these grid lines kind of perfectly. So one is at 110 here, and I'll do the other one at 3 and 20. Okay, so I'm going to do my rise and my run first, and then I'll show you the new way and show that it's the same answer either way you do it. Okay, so I'm going to go up 2 boxes, but each box is worth 5. So let me zoom in a little bit. My rise is actually 10 because each box is worth 2, or each box is worth 5 on my y. My run, each box is still worth 1, so my run is still going to be 2. But because the axis changed, my rise is going to change. So my slope is going to be 10 over 2. My slope is equal to 5. Now, we can do it with rise over run, which is easy on a graph. But we could also do y2 minus y1 all over x2 minus x1. Okay? I'm going to show this now because it is important, because you can do rise and run on a graph, but if you don't have a graph, you can't determine the rise and run if you have 2 points. Okay? So I said this point was 1 and 10, and this point is 3 and 20. Okay? Now, the little 2 and 1 on the x and the y, that's just a way for me to kind of label my x and y's, just to keep everything organized. Okay? They're called subscripts, and they don't actually affect the numbers. It's just a way for me to order it. So I'm going to say that this point is point 1, and this one's going to be point 2. So if this is point 1, my x1 is 1, and my y1 is 10. If this is point 2, the x of point 2 is x2. The y of point 2 is y2. So now when I sub this into my equation, what I'm going to get is my y2 is 20. So 20 minus my y1, which is 10, all over my x2, which is 73, minus my x1, which is 1. Is it important that I did 3 and 20 as my x2, y2? Could I do x1, y1? Of course I have. It doesn't matter the order that you put them in, just as long as you keep the 20 and the 3 together and the 10 and the 1 together. Okay, so 10 or 20 minus 10 is 10. 3 minus 2 is 2. Sorry, 3 minus 1 is 2. So see, I get my rise, my run again. Okay, my slope again will be 5. So either way you do it, you get the same answer. Now let's talk about the intercepts a little bit. So the y-intercept, we briefly touched on it last week. So it's the point of a line of the value of y when x is 0. So it's where the line crosses the y-axis. Okay, so it's called the y-intercept, and it's represented by the symbol b. YB, well, we couldn't use y already because that's the variable for any value of y, any vertical value. So we're using b, which we'll get more into that when we talk about the equation of y. So let's determine or identify the y-intercept on the graph. That's going to be right where the line crosses the y-axis at 5 here. My y-intercept is at 0, 5 because x is 0. Now I chose these 2 points for my line to determine slope, but I could choose any 2 points. So let's choose 2 new points. I'll do these 2 and see if the line has the same slope. It will always have the same y-intercept. So rise over run, I'll do it easy. Let's go to the graph. My rise, I want to go up 3 boxes, and each box is worth 10. So my rise is 15. I'm going to go over 3 boxes to the right. So my run is 3. So I'm going to have 15 all over 3. And 15 divided by 3 is 5. Okay, so therefore the slope is the same. So it doesn't matter which 2 points I pick on my line, I'll get the same slope regardless of the 2 points I pick. So the slope of the line is always the same at any 2 given points. Okay. Now, if I'm given a table, I can find a difference in my y coordinates over my difference in x coordinates. Okay. So to the side of each, I'm just going to write difference for x and difference of y for my table. Okay. So that's what we have to use here. So in order to get from 2 to 4, I need to add 2. In order to get from 4 to 6, I add 2. Get from 6 to 8, I add 2. So my difference in x, when I calculate the slope, delta y over delta x, the difference in that x is going to be 2, because it goes up 2 each time. For my y's, I go 0 to 6 plus 6. I go 6 to 12 plus another 6, 12 to 18, another 6. So my difference in y is going to be 6. So to calculate slope, I have 6 over 2. So my slope is equal to 3. My y-intercept is the point where x is 0. I don't have x is 0 here, but what I can do is kind of work backwards. If I were to go -2, that would get me to x equals 0. If I go backwards up here, I'd have to subtract 6. So my y would be -6. So my y-intercept would be at 0 and -6. Kind of like what we did when we were doing patterning with an input-output table, except instead of input-output, now I'm calling them x and y, like they should be. Okay. So now I want to calculate the slope given 2 points. So I'm going to use the equation y2 minus y1 over x2 minus x1. So slope equals y2 minus y1 all over h. x2 minus x1. So the first thing you need to do is label x1, x2, y2, y. Or x1, y1, x2, y2. I'm going to say a are my ones. So 5 is the x of a, my x value for coordinate a. 3 is my y value for coordinate a. So that will be x1 and y1. B is 5 and 8, and I'm going to call this x2 and y2. Okay, so now I have y2. I said that y2 is 8. So 8 minus my y1 is 3 from a all over x2 is 5 minus, and this is important, when I have a negative, I have -5 for my x, I need to put that into the brackets. Okay, because otherwise I would be saying, if I throw 5 minus 5, that would be saying that x is 5 for a, which is not, -5. I need to ensure that I have -5. I'm subtracting that. Because two negatives make a positive. Well, 5 plus 5 on the bottom. Okay, so 8 minus 3 is 5. 5 plus 5 is 10. So my slope is going to be 1/2. This one. For this one, I have Q and R. Just to show that doesn't matter which one I call x2 and y2, x1, y1, I'm going to say that Q is 0.2 and R is 0.1. Just showing up the order, but the order does not matter. What matters is I keep my points consistent. Okay, so I said y2 is -9, so -9 minus y1 is going to be 5. x2 is 6 minus x1, I said was -4, so I need to put that into brackets to ensure that I'm subtracting by a negative, which turns into addition. So it still stays as -5 up here because the 5 was negative. This one will become 6 plus 4. So -9 minus 5 is going to get more negative, so it's -14. All over 6 plus 4 is 10. Or as a fraction in lowest terms, I can divide it by 2, so it'll be -7 over 5. Okay, and we're going to start to leave our slope more as a fraction, just because when we start to graph, it'll be easier. So if you need to pause the video at any time to get caught up, just tell the teacher. I'm sure they're a nice person. They will pause the video for you. So rate of change requires units, okay, because something is changing. So here I have kilometers per hour because my distance is changing with time. Meters per second, again, distance is changing per time. Meters per kilometer, my volume is changing per distance. Okay, so when the relationship is graphed, the slope represents the rate of change. Okay, so again, slope is rate of change in these graphs. So to find the slope of a line going 2 points, subtract the y values to get the rise, subtract the x values to get the run. Okay, so it's going to take 2 points. So the graph shows the distance or the relationship between time and distance. What is my slope? I just need to pick 2 points where the line crosses over the grid points perfectly. So right here at 5 and 0, that's a good point. That's at 0 and my y is 5. But I wouldn't want to pick like 3 here because I don't know what the y value is. Kind of halfway between 3 and 4. It might be exactly half. I don't know for sure. So I'll pick somewhere where it goes through perfectly. 6 and 2 right here. Good. 6 and 2, but again, we can pick any 2 points. Okay. So let's just calculate the slope off to the side here. M equals y2 minus y1 all over x2 minus x1. I can say which is 1, which is 2. Generally, it's easier if you do the x2, y2 as the point farther to the right. And this one is going to be my x1, y1. Just because you kind of go left to right, the x's, the smaller value will always subtract, so your x denominator is going to be constant. Okay, when you go bigger number or higher x value, it's your 0.2. Okay, so I have my y2 is 2 minus my y1, 5 all over. I have 6 minus 0. It's nice when I pick that point, which is my y-intercept, because that just becomes 0. So I'll have -3 over 6. Slope is equal to -1. So it's -1/2. So what does this mean? We're going to look in terms of our actual units here, okay? So my slope would be -1/2 And we always go the y unit over the x unit. So the negative 1/2 meters per second. Okay, and this is Tracy's walk. Okay, so what does this mean? This means that Tracy goes 1 meter. I don't think negative 1 meter, but like probably going closer to home. Goes negative 1 meter every 2 seconds because time is my x. So that's why I like it more as a fraction, because I can clearly see that is 1 meter every 2 seconds. Those are my units right here. Okay, so everything matches up. So my y-intercept, I used that point. It was 0 and 5. So what does this mean? It means that Tracy was 5 meters from her starting point, or from her destination. If we say that her destination is at point 0, she was 5 meters away from where she wanted to be. So again, we could use rise over run to calculate the slope on that one. But y2 minus y1 over x2 minus x1 can be used for anything. Okay? And something like this where my scale is kind of huge on my x-axis. Okay? So this graph shows the relationship between temperature and altitude. Wait, does it say how far it shows from home? I'll just have this. Okay, so we want to calculate the slope of the graph. Okay, so again, I'm going to pick x1, y1, that's my point furthest to the left. And x2, y2, that's my point furthest to the right. So calculate slope. I do y2 minus y1 all over x2 minus x1 is equal to, my y2 is 13 minus 25 all over my x2 is 2,200 all over 200. Okay, 13 minus 25 is going to be negative 12 all over 2,000. Okay, I can make this a little bit simpler by saying negative 6 all over 1,000, which I could even make that smaller. Negative 3 all over 5,000, 500. I divide both my top and my bottom by 6, and by 4. That's my brought down a little bit. So that would be my slope. Negative 3 over 500. So if I want to interpret the slope as a rate of change, that would be, my units are Celsius and altitude. So it would be negative 3 over 500. And I need my y unit first, so degrees Celsius per meter. Okay. Or if you're interpreting it like this, it might be easier to put it as a decimal, which 3 divided by 500 equal to negative 0.006 degrees Celsius per meter. Okay, so what does this rate of change actually mean? We're talking about temperature and altitude. Okay, so altitude is just how high something is off the ground. So it's generally used with planes. Okay, so we can see that as my run increases, as my x value increases, my temperature decreases. It's a negative slope because it's going down to the right. So that means that as, we'll just say plane. The plane's altitude increases. And we can even be specific as it increases by 500 meters. So as it increased by 500 meters, the temperature will decrease by 3 degrees Celsius. Okay. So as one goes up, the other can go down. Okay. Reversely, if I were to get closer to the ground, my temperature is going to increase. Okay. So that's it for today. You're now going to get a worksheet to practice problems on your own. Hopefully, this all makes sense. I'll post this filled in version on SDLE in case you missed anything. And I'll be in tomorrow to answer any questions, and we'll kind of review it as well. Okay, have a good day.